Hey everyone, welcome back. Ready to dive into some seriously big ideas today?
Always up for a challenge.
Great, because today we're going to tackle something called the Size Scale Theorem. It's a framework that tries to connect everything in the universe,
Yeah.
from like tiny particles to those massive galaxies out there.
Yeah, it's a pretty ambitious undertaking, trying to unify all of reality into a single framework.
Right. So we're going to be unpacking excerpts from this book, and it gets pretty deep. Blends philosophy, science, even a bit of existentialism in there. Should be fun.
I think what I find most intriguing is how it all starts the size scale theorem. It uses the act of thinking itself as like the foundation.
Oh, you mean like that Descartes thing? I think, therefore I am. I
Yeah.
vaguely remember that from college.
Exactly. Even if everything else is like an illusion, the fact that you can think, well, that proves you exist, right?
Yeah, I get that. So the book takes that idea and runs with it.
Runs with it for sure. It introduces this concept of distinction, like our ability to separate ourselves, the thinkers, from the world around us.
Okay, so that makes sense. That's how we analyze, categorize things, like make sense of this messy reality.
Exactly. But here's the thing. It doesn't just stop at distinction.
I knew there was a but coming.
Haha, right. It introduces this idea of anti-distinction, like a counterpoint.
Okay, so what's that then?
So it's the idea that, yeah, we can categorize separate things, but ultimately everything is actually interconnected.
So it's not about like choosing one or the other.
Right. It's recognizing that both distinction and anti-distinction are needed.
Gotcha. So kind of like, I don't know, looking at a forest. You see individual trees, but it's also one big ecosystem, all connected.
Perfect analogy. You need both perspectives for the full picture.
Makes sense.
Yeah.
So how does this play out in different fields, this whole distinction, anti-distinction thing?
Well, take philosophy, for instance. You've got that classic debate, mind versus matter, dualism versus monism, all that.
Right. Vaguely rings a bell.
Well, distinction and anti-distinction can help bridge that gap. On one hand, we analyze our thoughts, separate from the physical world. But on the other, we recognize that both mind and matter are actually influencing each other.
Okay, I can kind of see that. What about in science? Does this come up there too?
Absolutely. Probably one of the most mind-boggling examples is in quantum physics, quantum entanglement.
Oh yeah, I've heard of that, but it's always sounded so weird.
It is weird. It's where you have two particles and they're linked no matter how far apart they are. Like change one and the other one instantly changes.
Like voodoo or something.
Yeah.
But on a particle level?
It kind of defies our normal understanding of cause and effect, but it shows how deep this interconnectedness goes.
Wild stuff. Okay, so before we get lost in quantum land, the book also talks about this infinite size-time continuum. What's that all about?
That gets to the core of the size scale theorem. It's saying reality exists on this huge spectrum of scales,
Yeah.
from the super tiny to the unbelievably massive, and across vast stretches of time.
So no matter how far you zoom in or out, there's always more.
Exactly. No limits on what we can discover. There's always another level, another layer of reality waiting to be explored.
Makes you feel pretty small, huh? Knowing how much is out there.
It definitely puts things in perspective. But it's also exciting. Means there's always something new to learn. So how do we even begin to make sense of this huge E continuum?
Yeah, how do you break that down?
Well, the book divides it into three categories: the microcosm, the mesocosm, and the macrocosm. Think of them like layers of reality.
Okay, break it down for me. Microcosm. That's the small stuff.
Exactly. The realm of subatomic particles, quarks, that whole quantum world. Things get really weird there.
It's like Alice in Wonderland, but instead of tea parties, it's quantum physics. And where did WE fit in all this?
We're in the mesocosm, the middle ground, so everything from cells, organisms, to ecosystems, planets, even human societies. It's what we're most familiar with.
Right, the stuff we can kind of wrap our heads around. And I'm guessing macrocosm is the really big stuff.
You got it. Stars, galaxies, clusters of galaxies, maybe even the structure of the universe itself. That's the macrocosm.
Wow, okay. So we've got these three layers, micro, meso, macro. But are they totally separate or what?
That's the key. They're not isolated. They're interconnected. What happens on one level can have huge GE effects on the others.
Like a domino effect.
More like a cosmic web connecting everything, with threads of influence running through all the scales.
Can you give me an example of that? how something on one scale might affect another.
Sure. Think about cosmic radiation. It comes from distant events, right? Like
Yeah.
supernova explosions out there in the macrocosm. But that radiation can reach Earth and affect things on a tiny scale.
You mean like messing with our DNA or something?
Potentially, yeah.
Yeah.
It can influence genetic mutations, maybe even play a role in the evolution of life itself.
Wow, that's pretty wild. So even tiny changes here could be linked to events happening billions of light years away.
Exactly. It's all connected. But what is it that actually connects all these scales? What's the stuff of reality, so to speak?
Yeah, what is that fundamental stuff?
Well, to answer that, we have to bring in one of the most famous equations ever, E m c,
Einstein. Good old Albert. But how does that tie into all of this?
because it tells us something hugey. Energy and mass are fundamentally the same thing, just different forms of the same stuff. And that stuff isn't just floating around. It interacts with and shapes the very fabric of reality, what we call space-time.
Hold on, I'm trying to wrap my head around this. So energy and mass are like two sides of the same coin.
Exactly. And they both are intertwined with space-time itself.
Okay, my brain's getting a workout.
Yeah.
But how does all this energy, mass, space-time stuff actually play out across the different scales?
Great question. Let's start small, down in that quantum realm. Ever heard of particle-wave duality?
Vaguely. Something about light being both a particle and a wave.
You got it. It's like something can be two things at once until you try to measure it.
So in that quantum world, things are kind of fuzzy. Not so fixed.
Exactly. And then there's the Heisenberg uncertainty principle, which says you can never know both a particle's position and momentum with perfect accuracy. It's like nature's imposing a limit on how much we can know about the microcosm.
It's like the universe is playing hide and seek with us down there. Okay, but what about on a scale we can grasp? Like in biology, for instance.
Well, think about life itself. Every living thing is essentially an energy transformer, right? We take in energy, use it to fuel our bodies, release it back out.
So even eating lunch is this whole energy, mass, space-time thing in action.
In a way, yeah. It's all about that flow of energy shaped by the laws of physics.
Okay, that's way cooler than how I usually think about my sandwich. But what about on the grandest scale, out there in the macrocosm? How does this all play out?
Think of stars. They're these massive furnaces fusing hydrogen into helium, converting mass into energy. That's nuclear fusion, releases a ton of energy, light, heat, all that. That's what makes them shine.
Definitely more impressive display than my sandwich.
Yeah.
But what about gravity? Where does that fit in?
Ah, gravity. It's what shapes the universe on the largest scales, right? And according to Einstein, it's not a force acting at a distance, but a warping of space-time itself caused by mass and energy.
Whoa. So massive objects like stars are actually bending space-time.
Exactly. Like imagine a bowling ball on a trampoline. It makes a dip, right? If you roll a marble near it, it'll curve towards the bowling ball. It's kind of like that. But with space-time instead of a trampoline.
Okay, I can visualize that. So from the fuzziness of quantum stuff to the warping of space-time by stars, it's all connected by this energy, mass, space-time idea. The Size Scale Theorem is giving me a whole new way to think about how the universe works.
It's definitely mind-expanding, but we've just scratched the surface. Remember, the book also says that evolution, something we usually associate with biology, is actually happening on all levels of reality.
Wait, hold on. Are you saying rocks and planets are evolving?
In a way, yes. But we'll dive into that more next time. It leads to some really fascinating questions about change, progress, even our own destiny as humans.
This is getting really interesting. Can't wait to unpack that more. All right, so last time, things got pretty wild, right? We talked about distinction versus anti-distinction, that whole infinite size-time continuum, and how energy, mass, space-time is like the puppet master of reality.
It's a lot to take in, for sure.
It is. But it's also kind of cool how all these different ideas are actually connected. And that brings us to maybe the most intriguing part, this whole idea of evolution as a universal process.
Right. It's not just about biology anymore.
Yeah, that's where I need some convincing. I mean, I get evolution with like genes and natural selection.
Yeah.
But you're saying it applies to everything.
Exactly. It's not just about organisms. It's about how any system changes and adapts over time, no matter the scale.
Okay, but give me an example. How can something like quantum physics be evolutionary?
Let's go back to that quantum entanglement thing. Remember, those link particles, no matter how far apart. Some physicists think that when you measure one of them, its wave function collapses. Like it chooses one state out of many possibilities.
So it's like a coin flip, but on a cosmic level. Only one side wins when we look at it.
In a way, yeah. It's not exactly genes in competition like Darwin talked about, but it does have that same flavor of variation and selection. Out of all those possibilities, only one becomes real in our observed reality.
That's wild. But it still seems different from, like, a new species evolving.
Of course, biological evolution is super complex, but the size scale theorem isn't trying to replace that understanding. It's saying bioevolution is just one example of this bigger principle, recursive adaptation, happening everywhere.
Recursive adaptation. Sounds fancy. What does that even mean?
Think of it like this: each stage of evolution builds on the one before it, creating more and more complex systems as time goes on.
So snowball effect of complexity.
Exactly. And we see it all around us. Like technology, we started with simple tools. Now we've got AI and smartphones and who knows what's next. Each innovation builds on what came before.
It's kind of crazy how fast tech changes. I remember when flip phones were the cool thing. But what about things that don't seem to evolve? Like rocks, planets, they seem pretty static.
That's where timescales come in. Sure, a rock seems unchanging to us, but over millions of years, it goes through weathering, erosion, even geological transformations.
So it's not that they're not evolving, it's just happening too slowly for us to notice.
Exactly. Our human lifespans are like a blink compared to cosmic time. But change is constant, even in the things that seem most still.
Okay, I can get behind that. But what does this mean for us humans? Are we be subject to this universal evolution too?
The book says yes, absolutely. We've evolved biologically, and now our culture, our technology is evolving faster than ever. The question is, where is it all taking us?
Yeah, where are we headed? Does it mean there's like a goal, an endpoint to all this?
That's a common misunderstanding. The size scale theorem actually challenges that idea of a fixed endpoint. It's more about the process of becoming, exploring possibilities, getting more complex, constantly adapting.
So it's not about the destination, it's the journey. Sounds a bit like a cosmic self-help book.
Maybe. But there's also a practical side to it. It changes how we think about our choices, our actions.
Okay, now you got my attention. How so?
It tells us to be open to change, to new possibilities, to constantly question what we think we know, and to remember that our actions have ripple effects on ourselves and on the future of evolution itself.
That brings up ethics, right? If we're all connected in this web of evolution, does that change how we think about right and wrong? Like, is there a new kind of morality here?
That's a tough one, and the book really tries to tackle it. It says, recognizing this interconnectedness, our role in universal evolution, it should make us more responsible, not just for ourselves, but for the whole system.
So it's not just about being a good person in the usual sense. It's about doing what's good for the whole web of life.
Exactly. It challenges us to think bigger than individual actions, to consider how our choices affect everything, from tiny organisms to the future of our planet, maybe even the cosmos itself.
That's a lot of responsibility.
Yeah.
How do we even begin to make choices that benefit the whole system?
That's where it gets tricky. The size scale theorem doesn't give us easy answers. It recognizes how complex ethical decisions are, especially with systems we barely understand.
So no cosmic rulebook to follow. Just got to keep asking questions, keep learning, and try our best.
Pretty much. It's about being humble in the face of how vast and complex the universe is. We don't have all the answers, but we can still choose to be a part of this ongoing evolution.
It's a lot to take in, this whole evolution is everywhere thing. Humbling, but also kind of inspiring. But where do we go from here? How do we use these ideas to actually build a better future?
That's the million-dollar question, and I think it's a perfect lead-in to the final part of our deep dive. We'll be back to explore those implications, so stay tuned.
Okay, so we've journeyed from the tiniest quantum particles to the vastness of the cosmos. It's been a wild ride. But now, for the big question, what does all this mean for our future?
Right, it's all very mind-blowing. But where do we go from here? How do we actually use these ideas?
Exactly. Yeah. It's easy to get lost in the abstract stuff, but I want to bring it back down to earth.
Yeah.
Like, what does the size scale theorem mean for our everyday choices, you know?
Well, one area it has huge GE implications for is technology. We're developing all these powerful tools, AI, genetic engineering, all that. And this framework reminds us to be careful to think about the consequences.
So not like rejecting progress, but approaching it with more responsibility.
Exactly. Every new tech has the potential to disrupt things. And those ripples, they can spread across all levels of reality. So we got to ask, Will this tech actually benefit the whole system or just create new problems?
It's almost like we need an ethical checklist for any new tech, right? Make sure it aligns with this whole interconnectedness thing.
I love that idea. It's not just about the immediate benefits, it's the long-term impact on everything, the environment, society, even the future of humanity.
Yeah, it's a lot to consider. And this goes beyond just tech, right? Like how we organize ourselves as a society.
Absolutely. The size scale theorem kind of throws a wrench into those systems that focus on competition and scarcity. It's like, hey, that's not how the universe really works. Look around, everything's interconnected.
So instead of a dog-eat-dog world, we need systems built on cooperation, like we see in nature.
Exactly. Imagine economies based on sustainability, not just profit. Political systems that emphasize collaboration, not conflict. And social structures that foster empathy and belonging for everyone.
Sounds pretty radical compared to how things are now, but also kind of hopeful. Is it even possible to create that kind of world?
It won't be easy, but change is a fundamental part of the universe. Systems evolve, they adapt, sometimes they transform completely, and we can be a part of that.
So it's not about having some utopian fantasy, it's understanding how change works and helping steer it in a good direction.
Exactly. Big systemic change is essential, but the size scale theorem also says our individual choices matter too.
So even small actions can make a difference.
Absolutely. Every act of kindness, every step towards sustainability, every time we choose understanding over division, those all contribute.
It's kind of empowering, right? Knowing that in this vast web, our choices still have an impact.
It is. And the more we understand the size scale theorem, the more we'll see how we can align ourselves with these universal principles, create a future that's truly in harmony with the cosmos.
This has been an amazing deep dive, I gotta say.
Yeah.
From distinction to anti-distinction to evolution happening everywhere, it's definitely changed how I think about, well, everything.
It's a framework that keeps you thinking, that's for sure. And that's the beauty of it. It's not about having all the answers. It's about embracing the mystery, the interconnectedness, and the fact that reality is always evolving.
Well said. So as we wrap up, I'll leave you with a question to ponder. If this whole idea of universal evolution is true, what's next for humanity? What role will we play in the unfolding story of the cosmos? Thanks for joining us on this deep dive. Until next time, keep exploring, keep questioning, and keep those minds open.